Okay, 3C, we're back to take a closer look at the problem that I told you to think about. Hopefully you had a little bit of time to think about it and maybe even come up with an equation. But that's what we're going to do now. We're going to take a look at the overall picture of what an exponential growth looks like and what the equation is going to look like. So let's take a look at the numbers. I'm pretty confident you guys could all double numbers. So the one thing that I want you to notice is that it moves along pretty slow. So, at the end of the first week, you only have $6.40. So it's kind of looking like, maybe I should have taken the $1 million on day one. But then take a look, by the end of the second week, you're up to $819. And it's like, this is growing pretty quick. If I went from $6.40 at the end of the first week to $819 at the end of the second week, maybe I shouldn't be too hasty about this. What's it going to look like after 4 weeks? But that's still a far cry from the $1 million that I told you you're going to have at the beginning of December. Now, I don't really want to keep doing this all the way to the end of December. It'll get us there, and it's pretty easy to double numbers, but it would be nicer to have an equation. So here's what we're going to do. We're going to take a look at what this looks like, kind of in the general term. So let's take a look at what we're doing here. So we start off with 5 cents, day one. This is our starting value, or our initial value. And then each day, here's what happens, is that we take the value from the day before and we times it by 2. So what I have is the value from the day before, and then I times it by 2. So that's what this 10 cents is. Now this 20 cents is the value from the day before, so it's this 10 cents times by 2. But I'm not going to call it 10 cents, I'm going to call it 0.05 times 2, and then I need another times 2. Hopefully you're starting to see a pattern here, because I'm going to do the same thing down here. So this 40 cents is really 0.05 times 2 times 2, which was the value from the day before, and then I had to double it again to get my 40 cents. You can plug that into the calculator, make sure that, but you can see that we're just doubling it a whole bunch of times. Okay, and that's going to continue. 0.05 times 2 times 2 times 2 was the value from the day before, and now I just have to double it again. So we've already done our exponential unit, so hopefully you can actually write this as an exponential. This is 0.05, and then I have 1, 2. This one down here is 0.05, and then I have 2 2's. This one here is 0.05 multiplied by 3 2's, so we need 2 to the exponent 3, and so on and so forth. So that if we go down to 15 down here, we have 0.05. Now, how many times have I multiplied by 2? We got to figure out what number's up here, because I don't want to fill in all the previous ones. Let's see if we can spot a pattern. Well, what was this number compared to what we have over here? Now, hopefully you can take a look at that and see, well, that number is just the same as this day number, which is actually one behind the date. Okay, the day number and the date aren't exactly the same thing. So if we take a look, since this is December the 16th, we know that it's actually day 15 since we started on day 0. Okay. So what that means, if we keep going on on the 31st day, on December 31st, that will actually be day 30 in our experiment, or our sequence. So that's going to be 0.05 times 2 to the 30. Now let's see what 0.05 times 2 to the 30 is. Now we know that exponential growth gets big in a hurry. I'm going to pick up my calculator. 0.05 times 2 to the exponent 30 is, here's the number on my calculator, give it a try on yours, 5368791 decimal 2. Now that's a pretty big number. Let's put in our commas to see how much it is. That is $53 million, ladies and gentlemen. Okay, so 53 million versus what I told you I would give you at the beginning of the month, which was 1 million. Okay, I think we've got a clear winner here. $53 million. You'd be better to wait the month, because remember, you're splitting it amongst 22 people as well. So let's see what this looks like on a graph. So we're going to go and take a look at what this looks like on a graph. I need the whole page up again. So here's what it actually looks like. I've graphed the first 15 days. I haven't graphed all 30 of them because that just gets whopping big numbers up the side. And so this is what I want you to look at, and this is the way we can tell what an exponential graph looks like. An exponential graph starts off slow. It's pretty flat, and it stays flat for a fairly long period of time, and then it starts to take off, and it eventually ends up going pretty much vertically. Now, it depends on the scale that you actually use, how quickly you're going to notice that vertical growth. But that's the way we can tell an exponential graph. And I'll just click here. I put the actual line on there. You can put your own numbers and stuff on your graph, but that's what an exponential graph looks like. Starts off slow, builds, gets quicker, and it almost goes vertically. Now, that's really good when you're talking about your money increasing exponentially, and when you put your money in the bank, your money does increase exponentially. Not quite as quick as this. This is a doubling curve, so it doubles every day. Exponentials, when you're talking about money, they certainly don't double every day. They take a long period of time to double. So, but exponential growth is really good when you're talking about doubling your money and putting it away and having your money grow exponentially. But we're currently experiencing a situation where exponential growth is happening and it's not so good, and that is in the case of infectious disease. And so we can take a look at a couple of these pictures that I pulled off the internet this morning. That is as of March 25th. I believe we're the 25th of March right now. Or is it 26th? What day is today? Oh, it's the 27th. I'm losing track of time. Okay, so it's the 27th of March. These were the numbers that I got off the internet this morning for what's happening with the coronavirus right now. And so if we can just take a quick look, this is the Canadian one, and you can see the exponential growth at work here. You can see every day it's a pretty flat, and then it starts to get steep. And it's getting steeper and steeper as the days go by. And that is because we are having that exponential growth happening. And you can see that mimicked across the world as well. It starts off slow, and it's not quite as exponential. The Canada graph looks almost perfect exponential. There's a little dip in here, which could have been as a result of fewer tests being done that day or something along those lines. But there's our exponential growth of disease. And so you need to keep that kind of thing in check, and that's what we're doing right now. We're trying to flatten that curve so that it's not growing quite as steeply, so that our healthcare workers can take care of it. Anyway, that's your exponential growth for today. You'll have a few questions to deal with exponential growth to see if you can spot the patterns in other situations. And that's it. Talk to you later.